Standard form, unlike slope-intercept form, is when you have an equation that has x and y on the same side being added together or subtracted, I suppose, not when you have y equals. So if we want to graph a line in standard form, one thing we could certainly do, and one thing that I would probably do, is honestly, I would just rearrange and solve for y. I'd put it in slope-intercept form. But let me go ahead and show you the trick for graphing in slope-intercept form, or for standard form, if that's something you'd like to try. So here's an equation we have in standard form. X and y are on the same side. I call the trick the cover-up trick, and it works better when I'm in class because I can actually cover things up, but we'll do our best to see how this works here. So what I'm going to do is basically cover up one of my variables, thereby making it equal to 0. So first of all, I'm going to cover up x. I guess I'll just scribble it out in this case. So I'm really making x equal to 0 when I cover it up. If you think about y, if I plugged in 0 for x, 5 times 0 is just 0, so it would vanish. So what's left is this equation, 2y equals 10. Well, if I solve that equation, I end up with, by dividing by 2, I end up with y is equal to 5, which really is going to be one of my points. And specifically, it's going to be an intercept. We'll take a look at which intercept that is in a second. Okay, well, the cover-up method for graphing in standard form means, well, we're going to need a second point. So what I'm going to do is, let me uncover up that, I suppose. And I'm going to find my second point. This time, you can probably guess correctly, I'm going to cover up y. So I'm going to ignore y, thereby making it 0. It's really what I'm doing. And I want to solve this equation that's left over, 5x equals 10. Well, if I divide both sides by 5, I end up with a solution of 2. So I actually end up with a second point, 2, 0. Again, those 2 points are really my intercepts. We can use just those 2 points to graph this line. I guess that's one thing that's nice about standard form. You only need 2 points. So let's plot the point 0, 5. So I'm going to move 0 left, right, then up 5. 1, 2, 3, 4, 5, and put a point. So I can see what that is. That's really my y-intercept, if I want to label that. I found where the graph crosses the y-axis, and I found the y-intercept by covering up x, which I know seems backwards, but it's just the way it goes. And then if I plot the point 2, 0, so 2 left, right, then up, down, 0, I can see that I've really found the x-intercept. So I get my 2 intercepts by using this method. Taking those 2 points, use a folder, a ruler, straight edge, do better than I'm about to do, and draw a straight line through those 2 points. Make it go all the way through your graph, add some arrows, and there's the line that we graphed in standard form. If you take the time and rearrange that to solve for y, you should see we get a line that looks exactly the same. One of the only nice things, I suppose, about standard form is that we can use it to set up some story problems fairly simply. So let's go ahead and set this problem up and then get a quick graph and figure out what's going on with Iron Man here. So I've totally made these words up, so they probably make absolutely no sense, but they sounded really fancy, so that's why I used them. So Iron Man's buying photon blasters, and they cost $3 million each. In addition to that, he's also buying biometric analyzers. Like I said, I have no idea what that means, but it sounds fancy. They cost $5 million each, and we have a budget of $30 million total. So using that information, as we've done a few other times in class, I can set up an equation. I'm going to say 3 times p, p representing the photon blasters, and if you want to make a note of that, go ahead and do it, plus $5 million a piece for those biometrics, so I'll use B for that, and I've got $30 million to spend altogether. So there's my equation. It's in standard form since x and y are on the same side, or I guess p and b in this case. If I wanted to solve for y, although again I don't really have a y, I could do that, but it's a little bit tricky because which axis would be the p-axis, which would be the b-axis. I'm just going to leave it in standard form and get my graph solved using that cover-up trick. So first thing is I'm going to cover up the p variable, thereby making it equal to 0. So I'm going to pretend p is 0. I don't buy anything, any proton, photon, lasers, or whatever I said they were. So the equation that's left over is 5b equals 30. If I divide both sides by 5, I get a b value of 6, so 0, 6. There will be 1 point on my graph momentarily. Next up for the cover-up method, I'm going to cover up the b value. So I'm going to make the b equal to 0. And let's see if I can erase and rewrite some of this real quick so you can figure out what I'm doing. Again, so much easier in class. So I'm going to make the b value 0. I'm going to pretend I don't buy any of those. And if I solve for what's left over, 3p equals 30, I'll divide both sides by 3 and end up with 10 as a solution. So there's my 2 intercepts. Let's go ahead and graph those, and then we're going to come back and explain what those values represent when we're done. So I need to label my axes. I don't have an x and a y, but I suppose I'll label this one the photons, I suppose. how many photon lasers I could buy, and I'll label the vertical axis, sorry, let's label the vertical axis those biometrics or whatever, okay? So X and Y, really. So my first point was at 0, 6. So 0 left, right, and then up 6. So I'm just going to assume my graph goes by the millions, I suppose. So 1, 2, 3, 4, 5, 6 million. So there's 1 point on my graph. The other point was 10, 0, so I'll buy 10 photon blasters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if I connect those 2 points, that line represents all the different combinations of things I could buy along the way. So my intercepts, as you can see from the graph, hopefully, those intercepts represent the extremes. Like if I were to buy all photon blasters, I could buy 10 of them, but I wouldn't have any left over for biometrics. Or I could choose to buy the other extreme. I could buy 6 of those biometric analyzers, but nothing left over. The line then represents my different combination of values in between. So this is probably the only situation where I would work with standard form instead of slope-intercept form. It makes it fairly easy, or easier, I should say, to answer a question like this.